The first topic in section 9.1 is rationalizing denominators. So it's not considered simplified to have a radical in the denominator. Therefore, to get an equivalent simplified answer, we have to multiply both the numerator and the denominator by the denominator itself. So looking at number 1, we're not supposed to have that square root of 7 there. So if I just multiply by square root of 7, and then to keep it legal, also multiply the top by square root of 7. So as long as you multiply by the same thing on the top and the bottom, you're going to get an equivalent answer. So what this will do is, on the top we'll just have 3 times the square root of 7, but on the bottom, the square root of 7 times the square root of 7 is just 7. So it gets rid of that radical. So 3 times the square root of 7 over 7 is equal to 3 over the square root of 7, but it's considered more simplified. Number 2, if you have the square root over a fraction, that's the same thing as saying the square root of the numerator over the square root of the denominator. So now I need to rationalize this by multiplying by the denominator. And on the bottom, the square root of 5 times the square root of 5, the square roots just cancel out and you're left with 5. On the top, the square root of 3 times the square root of 5 is the square root of 15. And this would be our answer. Let's see, and then lastly on 3, I want to get rid of that radical in the denominator, so I want to multiply by square root of 2 over square root of 2. And that's going to get me 4 times the square root of 2 all over 2. And then I can actually reduce here. So I can reduce the 4 with this 2. I can't reduce this 2 and this 2 because one of the 2's is on the inside of a radical, one of them is not. But those numbers that are outside the radical, I can reduce that, and 4 divided by 2 is 2. So I have 2 times the square root of 2 as my final answer.